Hello explorers and welcome to another video. Today we are going to convert Roman numbers. And Roman numbers is a sequence of numbers that uses letters to tell you a number, and it actually has an upper limit. You can't create a value larger than 4,000 or even 4,000. That's the largest value you can create with these numbers. And that makes them very simple to actually understand and implement. But there is some challenges in it. And you can't have negative numbers either, and so on. So I thought now that there is in the middle of the year, and we have this great advent of code that we run every year, and I was missing it a little bit. And then at work we needed this function to convert Roman numbers in PHP, and we went out, found a bunch of them on Stack Overflow, and I thought that this should be a pretty fun thing to implement and also to share with you and give you the opportunity to create your own. So I have created a little bit of a challenge. And if we switch over here to my screen, you see here that I have a repository called Roman numbers, and I'm going to link it in the description down below. And in this you have a bunch of test cases, 32 test cases on Roman numbers. And if you want, your challenge is to implement the function that actually converts to the Roman numbers. And if you want to, you can publish this and push to GitHub and then create a pull request on my branch here, so everyone else can see your code as well, because I think it's pretty fun to do things together. And if you want, you can create a code example that I can look at and comment on it. If anyone else wants to go in and look at the code and comment on them as well, you're welcome. But I thought that this could be a fun little challenge in wait for the new advent of code this year. So I'm gonna switch over to my development environment here, and here you see the function. It's num2roman. You get a number as an integer, and you need to return something that will satisfy these 32 test cases. And if you want to be in this challenge or want to do this, pause the video now and go and do the challenge and create a pull request, and then come back and watch the rest of the video if you like, and see what I come up with and how I go about it. So let's see here. First off, I want to check the test cases here, and I see that the negative test case is actually okay, and also too large is okay. So I chose, maybe not the correct way, but I chose that a negative number or a too large number should return null. So that is the state of a bad number. So if I change this null value here to an I, which is the number 1 in numeral numbers, and run this again, I should have only one test case that passes. The rest should be incorrect. And this is the test case for 1. So now I need to do some other things here. I think we can say that 1 is correct, and then I want to implement the incorrect ones. So if we have a number that is 0 or less, because we can't actually have 0 either, and then we will return null. And if we have a number that is 3099 over that value, that's incorrect as well, so we will return null there as well. So now we should have 3 test cases that passes. So we have actually taken a step forward. Now, if we have numbers in the Roman series, it actually goes that you write a bunch of I for 1, 2, 3, and if you want to do 4, you do it like IV, that's 4, and 5 is just v. So I want to fix those. So let's say that we have if a value, the number is could be divided by 1, then we will add to a string here. We can say string output and then put nothing, and in here we will add this I value like that, and then return output. So that should fix the first number. So modulus is good to use, I believe, for this. I actually got no correct. So let's see here, is it right divided by 0? Yeah, so now I got 29. If I do this 3 times, I should get a bunch of more test cases passing. Okay, I got only 29 as well, because it is actually divisible by a lot more things. So too large, negative, and 3. Yeah, because I need here as well to take the number and decrease it, of course, because I need to remove that number. So let's see here, I should get a few more. No, not. So, why not? Because I think I had 3 and 2 as well, yeah? Expected to got 3. Yeah, okay, if we do like this then, that should be no. So it's never dividable by 1. So let's do some output here. System out, print line number, that. And then just run 2 here. What happens here actually? 2, 1, 0. Okay. Expected to actual 3. 0, is that evenly divided by 1? Number larger than 0 and divisible. If we do it like that. Then it works. Okay, so 0 is evenly dividable by 0 times. Yeah, so that's good. So if we run the full test case here, we should get, we should take the full test case, we should get a bunch more test cases. Passing 1, 2, and 3 passes, negative passes, and 2 large passes. So now we have 5 test cases that actually passes. So, and I believe that and here we could continue up here. If we remove these numbers, could continue up here with 4 as well. So if it's evenly divided by 4, we should have added 4, and then we should remove 4. So then I hope that we will get one more test case correct. Yeah, So we should be able to continue here with 5, like that. Yeah, then we have 7, and 5 is also correct. If we do evenly divided by 9 and do ix, x is the next number up, and we do 10, like that. We should get a few more test cases correct. Yeah. 9 test cases correct. We have 1, 10, 2, 3, 5, 4, 9, too large, and negative. So now I have seen that the concept of trying different values out is actually working. We could continue here and doing the next one, and that should be 50. So that's L and VL, like that. So that's 50 and 40. So do 50 here and 50 here. I hope that will solve those as well. So we will have too large. 50 solved. 40 is not solved, of course, because it's XL. Yeah. So now we should have solved 40 as well. Yeah. So now I have a function that actually works. It does what it says. And what I want now is to make this a little bit more terse. Make it smaller, because this is a lot of code. And I want to see if I can make this smaller and perhaps easier to reason about. So let's first start off by creating a map with integers and strings. And that we call Roman. And here I want it to be 1000, and that should be the string n. Can I do it like that? IV and 1, just I. So that's the thing that we want to set up. We can have this Roman map out here. We can make it something static. We can have a static function here that just puts these in. So they are done, like that. So now I can do like this. I will have a for loop with the map entry of integer string entry of the Roman number up there. So this will be the entry set, like that. Then I want to incorporate this that I have there, like that. So I have output. So I will take this entry and check if the key of the entry is in that. And then I will do minus the key entry set here, like that. And then I want to run num to Roman number. That is what I want to do. And I want to return here directly. And I want to return the Roman, the entry get value plus the number down there. And here, if I get here, I will return null. So maybe there's a little bit more clunky version of a function might work. This is what I wanted to try. I wanted to check if I can make something that it is recursive that will solve all of these test cases. So how it works is that it will go through the set from the beginning. So if we see that the first value is 1,000, now that will not work. I think we actually need to create a list as well. I'm not sure, but I think we need to have a list of Roman numbers. Those are integers, array list, because I think the map is not in order. Might be able to create an ordered list, but let's just do like this. Add all the numbers we have here, and one. So that should be the same list, because the order is important. I want to take, if I see 1,000, I want to see if it's dividable equally by that 1,000. Remove that from the value, and then let's see here, we can take it like this. Num. So I want to first off do this like this, and then here I want to have the Roman get that value. So if I find it's dividable, I will decrease, add the character, and then add whatever the recursive function will return for me in the next iteration. So if we say it's 2,000, for instance, it will go in here, check the first number, if it's divisible 1,000, yes. It will remove 1,000, have 1,000 left, and run the function get the m, add that, and then run the whole function again and see, okay, it's still 1,000 left, it's divisible 1,000, we will remove that value, and we will check for this value here, and then return this. And up here, if the number is less than 0, we will return, okay, but we should get null down here as well. So if it's less than 0, then we will just return, but we need to check, we will need to get down to 0 in order to get this. Hopefully we'll not get a null in the end. That would be very unfortunate. Yeah, let's test this and see if it works, or if we get an issue here. We get just 2 passes, so we have an issue here. So let's see here. We do like that. 15 passes, okay? Why does this not work? 900 worked. I think we need to take, we get it turned around. Actual expected LI, but got IL. So let's test this one, see what happens here. So we run this and debug. Let's see what happens here. We get here, we have 51, 900, 400, 90, 50. Okay. That's why we get it. So this value is no good. How do I get the reminder? Now that was not the right one. If we do double here, and see if we can divide it by number, and we still have a larger value than 0. How does this work? No. Of course not. Divided larger than 1. If we can divide it by the large number and get more than 1, then we are golden. Let's see here. Yeah, now it seems to work better. So 50, it's more. Then we can go in there. It will run again. And divided by 1. So 1 will not work. So let's try with very close to 1. 51 works. Okay, so if we do like this, if it's more or equal to 1, because that looks better, yes. So now if we test all the test cases, what do we get? 1 failed. The number 6. Why doesn't 6 work? Because the test case was incorrect. Everything passes. Oh yes! So my idea worked. But I had to change it up a bit. So I think this function is actually pretty simple to understand. We have a number that goes in, we check that it's not below 0, because that is not a valid number. We check that it's not above 3,999, because that is not a valid number either. And if it's 0, we don't have any number in the Roman number series, so it should return the empty string, I guess. And then we go through a series of numbers that we have created up here, and I wanted them to be in order because I want to take away the largest number first. So I start with 1,000, and if I have something that is divisible by 1,000 and larger than 1, so if we divide it by 1,000 and get 1 or more left, so it's divisible by 1,000 at least once, then we'll remove that 1,000 and we will add the character for 1,000, which is an m in this case, and then we will run the function again and try the next number that we see. So this will go through and take out all the numbers and work with any number in this series, I believe. Because we have a lot of test cases that can check this out. So I guess I could make this simpler and easier if I have an ordered map, for instance. Then I could use that instead and get a little bit less code here, a little bit less setup in this static up here. But that's pretty much the simplification I can think about. So now I'm very curious to see what you come up with, what you think is a good way to implement this and do it in a nice way. Perhaps it's more code but more readable, or whatever metrics that you think is really good code. So I'm very curious to see what you come up with. If you create a PR and want to link your PR to your name on YouTube, leave a comment down below. If you have any comment suggestions, leave those down there as well. If you like this video, give it a like. Share it with your friends and colleagues. It really helps the channel. Another thing is, if you haven't subscribed yet, please do that. And I really hope to see you in the next video.